Here we are, question number 2. Let the function P represent the population P of D in thousands of a colony of insects. D days after first being measured. A model for P is P of D equals 10 times 1.08 to the power of D. Select all the statements that are true about this situation. Okay, so when you look at something like this, you probably want to read the instructions at least twice. Usually 3 times is best. Let's break this down a little bit. We've got this function P, this population P of D in thousands, a colony of insects, D days after being measured. So here's our model for P. P of D equals 10. Now let's highlight some stuff here. 10. You know what this 10 is? Here's where we're starting. We're starting with 10. We always put the beginning point right here at the beginning of our equation with exponentials. And what is it? 10 what? It's 10,000. So there's 10,000 bugs at the beginning. And then they say they're going to be multiplied times 1.08. You know what 1.08 is? That's an increase of 8%. If we convert 8%, if we convert that to a decimal, that's 0.08. And so if you're going to multiply times the population, you got to add 1 because we're gonna keep that original value of the population, right? So we already had times 1 is going to give us the original 10,000. We add the 0.08, right? So we multiply times 1.00 to keep the original 10,000, and that additional 0.08 is an increase of 8%. So what color are we going with? We're going with the orange. So we're going to multiply times 1.08. Here is our growth factor. We'll just keep multiplying times 1.08 and D days. So how often do we multiply times 1.08? D days after first being measured. Select all the statements that are true about this situation. So I think it's looking to me like every day. It's kind of crazy, right? With bugs are like that. They can increase very quickly in their population. 8% every day. This colony is increasing by 8% every day that passes. So now, let's read these statements and see which ones are true. It said select all. So we're going to look for probably, when it says all, usually there's more than one answer that is correct. So there are 10,080 insects when a colony was first counted. Okay, the colony, when it was first counted, if we're familiar with our exponential equations, we know that we started at 10,000. This is totally wrong. When it was first counted, we had 10,000. So that's definitely not right. You know when it hit 10,800, that would be, 1080. This would be after a week. A would be after 1 week. Oh, I'm sorry, 1 day. They're increasing by 8% each day. So that would be after 1 day. One week after the colony was first counted, there were 10,800. Oh, look, and now I'm realizing the question, part A was way even more wrong than I thought. We started at 10,000, way bigger than 1080. So that's definitely wrong. But part B here says 1 week after the colony was first counted, there were 10,800. That is after 1 day. After 1 week, what you're going to have is the 10 that we started with. Started with 10, and we're multiplying times 1.08 each day that goes by. But guess what? A week is 7 days, right? So you'd multiply times 1.08 to the power of 7. If 7 days goes by, we would have multiplied times 1.087 times. And 10,000 times 1.08 is 10,800. This would be after 1 day, that 10,800. After a week, it's a lot bigger than that. 1.08 times 1.08 times 1.08. And this 8% increase on 10,000 for 7 days would be a lot different than that. It's not this one. So now you might think to yourself, how am I supposed to know that? I don't have a calculator. What am I supposed to calculate this? They're kind of hoping that you have the ability to take 10,000, multiply times 1.08 after 1 day. And the way that this works is you count how many zeros there are. There's 1. If you multiply times 10, you'd move the decimal place over 1 spot. If you multiply times 100, you move it over another spot. 1,000, you move the decimal place over 3 spots. And then 10,000, there's 4 zeros. So we got to move that decimal place over 4 spots. And what we end up with is 10,800. And that was just after 1 day. So this cannot be after a week. That's kind of how they want us to figure that out. Don't stress too much. I'll try to make it more easy, a little bit easier to manage number than that. I won't give you such a giant number like that, just so it's not as intimidating as it is. The growth factor per day is 1.08. This is 100% true. Here is our growth factor. It's what we keep multiplying by. The growth factor is whatever's got the exponent next to it, because that's what we keep multiplying by each day in this case. So remember, we always start with the beginning, and then we got our growth factor with the exponent next to it. So this one is definitely true. C is for sure true here. And D, the growth factor per week is 1.08 times 7. Here is where they're trying to focus on, do you realize and understand what an exponential is and why we raise our growth rate to the exponent of 7 after 7 days. We're not going to multiply 7 times 1.08. We're going to multiply, basically what we're going to do is we're going to do each day that goes by, we're going to go times 1.08 times 1.08 times 1.08 times 1.08. This is each day that passes, right? So you do this 7 times. One, two, three, four, five, 6, 7. And guess what this equals? It does not, I guarantee you, it doesn't equal 1.08 times 7 like they're suggesting in D. That is for sure not true. This, my friend, is 1.08 to the power of 7. I wrote 2, 7 to the power of 7. 7 days went by. We're going to raise it to the exponent of 7. That's the whole point of this unit, learning about exponentials and how to substitute your numbers for the amount of time that goes by into the exponent position. So D is definitely false. If they had said to the power of 7, it would be 100% true. This would be true, but not times 7. No way, no how. That'd be something that had a linear function, not an exponential. So I'm gonna grab my green marker for yes. Or no. We're red, right. Red for wrong. Not this one. It's supposed to be 1.08 to the power of 7 after a week. And how about this last one? E. The growth factor per hour is 1.08 to the power of 1/24. So 1/24. What are they talking about? 1 out of 24. You know what's there's 24 of? There's 24 hours in a day. So if each day we're multiplying times 1.08, then, and only an hour has gone by, our exponent, see, here, check it out what happens. Each day, if 1 day goes by, We got 1.08. Jiminy Christmas to the power of 1. Here's after 1 day, okay? D, days is 1. But after only 1/24 of that day, 1 hour, there's 24 hours in a day, only 1/24 of that day has passed. And that is our exponent, and that is 100% true. E. So C and E. These are the droids that we're looking for right here. Here's our true answers.